Welcome to our another video. In this session we will be discussing the topic IoT aquaculture and hydroponics monitoring project design. It is a project that used the following sensor modules: Arduino Nano board, turbidity sensor module, TDS sensor module, pH sensor module, to measure turbidity of a water solution, the total dissolved solids, the pH level of the water and finally, its temperature. To make the project IoT-based, we had to include an ESP-8266-01, ESP-01, Wi-Fi module. We used this industrial pH sensor from DF Robot Store. It was what provided us with a form of precision that we needed to measure and know the pH level of the solution. And the TDS sensor with the Dallas temperature sensor that is waterproof, we could know the needed values of these given parameters for the solution. However, our turbidity sensor was the non-contact type and we connected it as shown here. The IoT part involved using the ESP-01 module and Wi-Fi with internet access to send the measured readings to the Blynk dashboard for remote monitoring. We could monitor the system either on our mobile or the PC from anywhere around the globe. Without further ado, let us discuss in details how this IoT aquaculture and hydroponics monitoring project design was built. But before we proceed to that stage, we would like to call to your attention to encourage us anyway that you can by subscribing to our channel if you haven't done so yet, liking and sharing this video if you like this. It is free and it would really mean the world to us if you did. Now, to continue, the first thing we need are the components and modules used in designing and building out the project design. Of course, we would need the Arduino Nano development board. This acts as the brain of the project design. It is the microcontroller that is responsible for reading the sensors connected in the project design. The Arduino Nano board allowed us to communicate also to the ESP-01 that was connected to project for IoT purpose. The program code would be written onto the Arduino Nano board in the later part of this tutorial. Next is the non-contact type turbidity sensor module. It allowed us to measure the quality of being cloudy, opaque, or thick with suspended matter in the solution. Whereas, the total dissolved solids, TDS, is the term used to describe the inorganic salts and small amounts of organic matter present in solution in water. This is captured by the TDS sensor module. You can find a link in the description below for more information. The pH sensor module was the industrial type sold at the DF Robot online store. And it was also cute to use. And using a DC to DC buck converter, bucked the output voltage from a pair of 3.7V batteries connected in series to 3.7V to power the ESP-01. To make the project permanent, we soldered it on a Vero board. We used a female header pin to connect the Arduino Nano board to the Vero board. A red switch SPST was used to isolate and introduce DC power into the system at will. We also used JST header connectors to connect the modules when needed. And the program was coded on Arduino IDE. Using Blynk IoT dashboard, we monitored the readings and measurement of the sensors. The water solvent was put in a transparent container box of a suitable dimension, whereas the electronic modules were enclosed in a 3 by 6 inch Patras box. The schematic diagram involved hooking up the Arduino Nano board to the sensor modules. We started with the TDS sensor and the temperature sensor, the DS18B20 waterproof type. We included a 4.7K resistor across the VCC and the data out, D0, pin of the temperature sensor so as to ensure the readings are accurate. Without this, the sensor would not work. Since the non-contact type of turbidity sensor module we got was using I2C communication protocol, We connected the I2C pins to the digital pin A4 and A5 respectively on the Arduino Nano board. See the link in the description below for more in-depth explanation. Wiring is neat with JST connectors, which makes replacing sensors a plug-and-play experience. The SPST switch ensures you don't drain the batteries accidentally. On the outside, the Patras box keeps everything protected while the water sample sits in a transparent container, making testing simple and safe. This Arduino code is designed to read data from various sensors and transmit that data via serial communication to an ESP-01 module. The sensors include a temperature sensor, a TDS, total dissolved solids, sensor, a pH sensor, and a turbidity sensor. Below is a detailed breakdown of the code. It would be also good to know that the project design has two Arduino codes, one for the Arduino Nano board itself, and the other, for the ESP-01 module, which is serving and acting as the Wi-Fi peripheral module in this project design. Once we upload our code to the Arduino board, we can see the readings on the serial monitor below. We can see the temperature, the TDS measured value, and the turbidity sensor value itself. Now, moving on to the next stage, which is the setting up the Blynk platform for the IoT-based remote monitoring of the project design. The Blynk platform allowed us to design the monitoring part of the project on both the mobile platform display and the PC-based display. For the mobile-based version, we used display gauge widgets that would show the value as well as the level of fill of the measured and monitored parameter of the solution. Whereas, for the PC display version, we used graphical charts that would represent histograms. We could see the measured parameters values in terms of how many hours ago they were seen, or in terms of its live readings, given a time delay lag of 3 seconds. To test out this project design, we had to individually test out the sensors themselves. which means that we had to test each sensor one after the other. We started off with the non-contact turbidity sensor module, and we used the case scenario as shown here. And next is the pH sensor module. And we calibrated and recorded the different pH levels for each solvent and solution we measured. And once we were done test each sensor module, we powered on the project design and ran the real live testing for the work built. And we monitored each part of it, from the sensor readings to the IoT dashboard, to see if each side corresponded to what is being measured and what is being sent to the IoT dashboard to be displayed. And that is it for us on this video tutorial of IoT-based aquaculture and hydroponics design using Arduino, ESP-01 and Blynk. We hope you have enjoyed it. If you have any questions, don't forget to leave a comment below. Until we see you again on our next video, thank you for watching. Goodbye and have a great one.